I'm going to go ahead even though Liz is not in here so we can get through. 5 I thought was the toughest one on the test for sure. So you got dB. dB dt equals 1/5 100 minus b. And so this was the rate at which a baby bird gains weight. And so there's my differential equation, and it says, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. So you had to plug in 40 grams for B first, and you found that the rate then was 12, is that right? So that would be grams per day. And then at 70, so when B is 70, you found that dB dt was 6 grams per day. This is number 5. You got 1 point just for using dB dt. To know that you needed to plug into dB dt and use that, you got a point. To understand that that was a rate is what it gave you. They gave you a point for that. And then your answer, because the rate at 40 days is more than the rate at 70 days, then he's gaining weight faster at 70 grams than he is at 40 grams because the rate is faster. That's all you had to say, and that was another point. So that one was 2 points. It was pretty easy. Most of you got that one, or you at least got the dB dt part. Part B, it started getting a little bit tougher. So they give you this graph. I think this is the one that I messed up on because I didn't read the question carefully enough, and a lot of you didn't either. It says, find the second derivative in terms of B. Well, that wasn't a problem, but I don't think anybody was able to find the second derivative with respect to B. So let me walk through that because this is a typical implicit differentiation problem. Okay, so we got 20 minus 1/5. So now we need to find the derivative with respect to t, right? The second derivative. So the second derivative with respect to t would be negative 1/5, right? But you have to do dB dt here because you're doing it with respect to t. So times dB dt. Well, what is dB dt? This is dB dt, and you have to plug. Remember when we were doing implicit differentiation and we had to solve it for dy dx, and then we had to plug back in what that original was? That's the same thing here. You got to plug it back in to get it. So this ends up being negative 1/5 times 20 minus 1/5b. You could have left it like that, or you could have, of course, distributed through. So that was worth 1 point. This was only a 2-point question. Then the hard part was use the second derivative to explain why the graph of B cannot resemble the following. So the point was that you had to use the second derivative. Well, what does second derivative tell us? Concavity. So the derivative of this. So it's just the coefficient in front. So because the second derivative from on this interval here that I'm on, right, in the first 10 days, the second derivative is negative based on my second derivative. Do you agree? If I plug in 1 here for B, I'm going to get a negative value. If I plug in 2, I get a negative value. In fact, for all these values, this should be negative, which tells me it should be concave down. This graph is not concave down here. So that's what you had to say. So they gave you this graph. This is concave up. Well, at least from right here. But all I had to do was use the second derivative to show that at some point. Oh, I don't know. But this is not the second derivative graph. This is supposed to be the original graph. So explain why B cannot resemble the following graph. Yeah. That portion is. Since it's always negative there, right. How would I graph what? You don't have to graph D2. Yes, it would be that would be linear, yes. And a lot of you put that, but that's not what they were asking. Why, okay, so they gave you the first derivative. You found the second derivative. Why is this not a good graph of the original function? So the integral of this, the backwards of this. Why could this not be the antiderivative of this? Because, correct. Because the second derivative would be negative in this area right here if you plugged any of those values in. So because it's negative there, it should be concave down, and it's not. Yes, their explanation, I'll read you theirs because I'll read you theirs instead, and then I'll read you mine and tell you the difference. So they found this, and then they said, therefore, the graph of B is concave down for between 20 and 100, a portion of the graph that is concave up. So they looked at between when Y was 20 and 100. And they said in that interval it should be negative. I said when it's less than 100, it's negative. The second derivative is negative, which would indicate concave down on that interval. But somewhere they want you to talk about concavity there. That's the point. And that was only 1 point, and I thought that was a lot you had to understand to just get 1 point for that. But I'm sorry. I didn't make it or buy it, but sorry. Okay, the kicker. Part C was worth a whopping 5 points. So we have a lot of you at least separated the variables, which gave you a point. When you've got something that's this hefty in points, they give you a point for crazy stuff sometimes. All right, so it says use separation of variables to find y equals b of t. So remember they gave us dB dt, 1/5 100 minus b. And it says the initial condition b of 0 equals 20. All right, so I got to separate the variables. So dB equals 1/5 100 minus b dt. So I'm just going to divide by this 100 minus b. There's your first point. Did you get them separated? The next point, what do you do from here? Well, yes, Dylan. Did you? You had this? How different does it look? I did already. You'd have to divide by that. And you don't do the plus C. But inappropriately on the same side. You would have to, this portion would have to be on the bottom. because you'd have to divide to get them separated. You see what I'm saying? Did you get the right answer?
I don't know. My answer is like really long.
100 minus 80 e to the negative 150. Do you have an e in it? I don't know. I remember seeing that there. All right. Next point, we integrate because
I didn't understand because I did 100 minus 0 plus c. And then I did 100 minus 1.
I'm not sure. Let me finish working on. We'll see. All right. So this is the whole point in this is that we isolate the b so that we can find out what the original equation was. Anytime it's in the bottom like that, that is the natural log. But chain rule is going to take over. I've got to multiply by -1. I did miss that -1 whenever I did it. So this is actually going to be negative log 100 minus b equals 1 point for the antiderivatives, 1 point for the constant of integration. You're already at 3 points and haven't done a whole lot of algebraic manipulation. So even if you couldn't get it from here, you've got 3 of the 5 points. Now is where we use the initial condition, which was b of 0 equals 20. 20. So we're going to put 0 in for t, and we're going to put 20 in for b. So we get negative log of 100 minus 0. Nope. I'm trying to see why that door. Good morning. Let's see why that door was open. 5 times 0 plus c. Now I just plug that back into C. So this is a point for using the initial condition is a point. So now I have negative log of 100, and I can drop that absolute value now. Minus the 150 minus log. Now I'm going to divide by -1 first. Because of this negative, I'm going to get rid of that first. Why would you leave it? I'm trying to solve it for b. Because that's the goal. This is the 5th point here, so this is the last point. All this, from this point on, to me is the hardest of the problem, and that's only 1 point. I've got -150 plus log 80. So now you're into just algebra. If I do e on both sides, I have the log of, I have 100 minus b equals e to the -1/5 times 80, because the e and the log cancel out. Well, so this is the same, e to all of this is the same thing as e to the -150 times e to the log 80. So this is really 100 minus b, 80 e to the -150. Now I'm just going to move that 100, and that's exactly right. Just switch them around to look a little prettier. You definitely don't have to. Yes? That one was tough. I have a star by that one. I left my negative out in the beginning. So hopefully, even if you can't get fully through that problem, start to finish, you could at least get the first 3 or 4 points. Separate the variables, integrate, you can do something. And if you ever start with d something, like they give you the derivative in that form, it's probably going to be a separation of variables. It's going to be a difficult that you're going to have to solve. Yeah, it said it. Yeah. All right, let's look at number 6, and I'll shut up and let you work. Between 0 and 12, particle motion. I thought this one was incredibly easy. You might not have agreed. All right, so I've got velocity that was given to me initially, cosine. Some of you forgot the chain rule. The particle is at position x equals -2 at time 0. So that means at s of 0, I am at -2. That's important. That's that initial condition. Okay, so between 0 and 12, when is the particle moving to the left? Well, the first thing I need to find, of course, I'm sure you can guess what I did, a sign chart. I didn't do a sign chart. I found when velocity was 0. You remember how to solve an equation that looks like that. Bless you. When is cosine 0? That's right. Hopefully it was the velocity.
And then that's why I found, yeah. I didn't like your function.
You did, yeah. I think you thought it through and you just wasn't, you didn't say velocity equals 0, but you found where it equals 0. And on this one, make sure you say it because your first point comes from, did you consider v of t equals 0? So they're looking somewhere that you set velocity equals 0. And that's a point. Not for solving it, but just for finding that. All right, so where is cosine 0? And I'm between 0 and 12. Pi over 2 would equal pi over 16. And 3 pi over 2. I don't go any further because my interval is from 0 to 12. All right, so this tells me here, this one, if I multiplied by the reciprocal, I would get t equals 3. And this one, I'm cheating using my paper. I already found them all. 9. So I came over here and I said from 0 to 12, I have 2 places where it's 0, that's 3 and 9. So this is the velocity, which will give me the position. Yes? So derivative gives you the original function. So between 0 and 3. So I'm thinking about on that unit circle, right? Between 0 and 3. I plugged in, if this was 1, what's the cosine of pi over 6? Is it positive or negative? It's positive. So I'm moving to the right. Between 3 and 9. So pick a random variable that works. I might pick 6. That's an easy one. So it's pi, negative. And then between 9 and 12, positive. So where is it moving to the left? 3 and 9. They didn't even ask for justification here. Just, I would probably say it still.
Yeah, I got that. Now I got one.
So you got 1 point. You got 1 point for if you have this or this somewhere on your paper. That's 1 point. And then I know. Listen, but that's what I say. Always write it down. And then the answer gave you 1 point. I know. Always write everything down, y'all. I know. So the interval is between 3 and 9 because v of t is less than 0 there.
Is this right here for the whole FRQ or just for like? Because there wasn't 9 points.
Always put a because. It didn't ask, but they'll want to know that you understand. So, okay, mine on this one, particle is moving left between time t equals 3 and t equals 9 because velocity is negative here. Theirs, the particle is moving left when velocity is less than 0. This occurs when t is between 3 and 9.
I didn't get it. I don't think. I did get it.
What?
Like I got it, the answer right. I don't think I got a point for this. I know I didn't say it equal to 0, but I still got the answer right.
I'll look at that one. Let me think if they wouldn't. Let me think about that one. Because of velocity.
Where did I lose my second point? Because like I didn't I said cosine of 0 at there and then plugged the points in, and then but I didn't
You literally have to cosine pi over 6t equals 0. Like they have to say, they have to see that you set the entire velocity equation equal to 0.
Yeah, I mean kind of did here, in this work.
Don't leave anything out. Act like you are. This is their elementary, and you're trying to show them step. I mean, they have to see everything.
You see what I'm saying though? Because I said cosine of 0 here, and then plugged it in to find those two values.
Right. All right, look at part B. Part B was a gimme 1 point. Total distance traveled is absolute value. All you had to do from 0 to 6, cosine pi over 6. They don't do half points. I know. But listen, part of this is so that y'all start seeing what they expect you to put. And it's tough. Sometimes it's tough what they expect. All right, that's all you had to put. That was your 1 point on B. You had to have the absolute value though. You could have even done this and gotten full credit. And the more you watch those videos, the more you'll hear Mark and Verge, who are like head readers, talk about those kind of things and talk about where you lose points and how many times they see students lose points for things like that. And they constantly harp on, make sure you write it, make sure you write it, make sure you write it. Because if they have a scoring guide like that and it's straightforward, I mean, they won't even ask about that. That'll be, no, they don't have it. So be careful. It does suck. It does suck. All right, part C. Noah Miller. No, this is not the one. Is this the one? Yes. I thought about you whenever I did this problem because you focused on this so much when we did it, and I don't remember if you got it right or not. First of all, the acceleration, which is the derivative of velocity. So if velocity, and this is where y'all forgot the stinking chain rule. What was it? Cosine pi over 6t. So derivative of velocity is acceleration. The derivative of cosine, negative sine pi over 6t and times pi over 6. That's 1 point. That is 1 point. 2 points for the conclusion. How do you know if a speed is increasing or decreasing?
I don't know, but I think my answer deserves more points.
Yes, but I was very confused. I was confused because the speed is absolute value. So like, I was like,
Noah, do you not remember? Speed is increasing when the sign of acceleration and velocity are the same at that point. It's speeding up. When the signs are opposite, one positive, one negative, that's right. So I have to find acceleration at 4, and I will spare you all that plugging in to tell you. Oh,
Did we get like one, like how do we get points on our answer? We wrote it out. Those 2 points.
The 2 points, no partial credit on that. Conclusion with reason. So the speed is increasing at time t equals 4 because velocity and acceleration have the same sign. And you have to show A of 4 and V of 4.
Wait a second, wait, what did you say?
You have to show A of 4 and V of 4. The speed is increasing at time t equals 0 because velocity and acceleration have the same sign. Or because they are both negative. Or
Okay, I put that.
what did you read it?
I said increasing because acceleration is negative and velocity is increasing from negative to positive. The speed is always positive because of the absolute value. But I did put they're both negative.
I'll go back and read it. I'll go back and read it. Okay. Speed is increasing, and this is something this is usually tested more on multiple choice as far as speed and velocity, but make sure you understand because it's going to be on there somewhere. Speed is increasing when the signs of velocity and acceleration are the same. When the signs are different, that's when it's decreasing. So this one is the speed is increasing at time t equals 4 because velocity and acceleration have the same sign. Because it says, the question says, is it increasing or decreasing at time t equals 0? I mean 4, sorry. I was like, what? You don't see that, Jesse? No, you don't, because it's 4. Okay, yeah. Correct. Now we want the position of the particle at time t equals 4. That's not distance traveled. I don't have to do absolute value. I don't have to do, all I have to do is for the position at 4, I need to do the integral from, what did it say, time t equals 4? 0 to 4 of cosine pi over 6 t dt, but I have to remember to add in that initial position. It didn't start at 0. It started at, I don't remember, -2. Okay. This was kind of a U sub problem here. Cosine of U, if U is pi over 6, du would be, if U is pi over 6t, du would be pi over 6 dt, so I need a 6 over pi outside to counter. I need, what's the antiderivative of cosine U? Sine U. And I need to change my bounds also because I let U be pi over 6. So I'm still from 0 to 4 pi over 6 is the same thing as 2 pi over 3. There are those unit circle values. I still need to add in that initial position. Then you do sine of 2 pi over 3 minus the sine of 0. We got that minus 2 there. What's the sine of 2 pi over 3? Square root of 3 over 2. Sine of 0. Let's see. 3 root 3 over pi minus 2.
That's what I got.
All right, so 1 point for the antiderivative. So if you knew how to do the U substitution, there's the antiderivative. 1 point for knowing that you had to use the initial condition, and 1 point for the answer. So 1, 1,